Hello everyone, I'm Declan McClintock. I'm an incoming computer science and engineering PhD student at Michigan State University with my bachelor's in computer science and engineering with a minor in game design and development, and today I'm going to go over some basic programming concepts for use in Unity. All examples in these slides will be using C#. First on our list are variables. Variables are used to store information. There are several standard types of variables available in C#. Integers and longs can store any integer value. Floats and doubles can store any decimal value. Strings can store any combination of characters. And booleans store true or false. There are also many more standard types that are less commonly used. Types can also be defined by code, either your own or another person's. Vector3 is a type defined by Unity for you to store 3 float values, x, y, and z. Most variables have methods that can be used through them. These methods usually do one of the following. They update the value in the variable, they return, or give back, a modified value without changing the original, or they read some value back from the variable. What you can do with the variable of any type is typically well documented. Microsoft's C# framework is available online and is easy to get to through a Google search. Similarly, Unity Scripting API, our application programming interface, is available on the web. There are also variables that store groups of a given type. Two examples are lists and arrays. Lists and arrays also have methods that can be used to modify or access data inside them. Here is an example of variables in a script. I'm going to break down this entire example line by line to try and avoid confusing you with what is and is not a variable. Lines 1, 2, and 3 are all using directives. What these are doing is saying that we can use code from each of these other collections of code. The first line appears grayed out because the code we have been writing in this script hasn't made use of any of the code within system.collections. These color codings are just a way for the tool we are using for writing code to give us information or make things more readable. In this case, the code examples are written using Visual Studios. If you use a different tool, your color coding may be different. Line 5 is a class declaration. This is saying that we are making a new class and all code within this block is part of this class. Public means this class is usable outside of the script. Class is stating that we are writing a class. Third-person camera is the name we have given our class. The :mono behavior is what's known as inheritance, which is a topic for another time, and the squiggly bracket marks the start of a block of code. In this case, it marks the start of our code for this class. The remaining lines are all variables where we can store information. The control manager and cursor manager are both types we've defined by creating classes for each. The game object and vector3 are both types defined by Unity. One important thing to notice is that the game object player is public. This means that if we create a third-person camera somewhere in another script, we can access its player variable directly. We will not be able to access the other variables, however, because they are set to private by default, and private variables of a class cannot be directly accessed outside the class they exist in. Next up are operators for logic. Operators for logic are things you will find you use a lot when programming games. Typically, you use these in if statements to help determine whether to run a block of code or not. The == checks if both sides are equal. If both sides are the same, it evaluates to true. Otherwise, it evaluates to false. Remember that a single equals is an assignment and not a comparison. != or bang =, or does not equal evaluates to true if the two sides are different and false otherwise. Less than =, is a less than or equal to check, meaning if the left side is less than or equal to the right, it evaluates to true. Greater than =, is the greater than or equal to check, meaning if the left side is greater than or equal to the right side, it evaluates to true. The less than and greater than signs work similarly. It's worth noting that not all types support these operators. The ampersand ampersand represents AND. If what is on the left side of the AND and what is on the right side of the AND are both true, then the AND gives true. Otherwise, it gives false. The vertical bar represents OR. If either the left side or the right side of the OR is true, then it gives true. If both sides are false, then it gives false. The exclamation point, or bang, represents not. It basically inverts the value on the right side of it, meaning if you have exclamation point true, you will get false. If you have exclamation point false, you will get true. Now we are going to look at if statements and conditionals. An if statement contains a block of code that is only run when the condition the if statement checks is true. In this example, the if statement is checking if the time.timescale is equal to 0. This is essentially just checking to see if the game is paused. If the time.timescale value is indeed equal to 0, then the code within the curly braces is executed. In this case, it is that single line that reads return. If the time.timescale value does not equal 0, meaning our if statement is false, then that code within the curly braces is not executed. Else and else if are a way of extending your if statements. Else statements can only come immediately after an if statement, and the block of code within the else is only executed if the preceding if is false. Similarly, else ifs are only executed if the preceding if, or else if, is false and the condition the else if is checking is true. In this example, we have an if statement followed by some else ifs. The code inside the conditional parts of this example are basically just Boolean values, meaning they are either true or false. If we had simple save load dot has reflective umbrella set to true, by the time we hit that first if in this example code, then the code block within that if gets executed and the two else ifs are skipped. If that first if's conditional were to evaluate to false, then the code within that if would not be executed, and the first else if in this example would be checked. If that check is true, then the code within that else if is executed, and the preceding else if is not checked. If, else, and else if are very useful when you want to have code that only executes under specific conditions. Now we are going to talk about for loops. For loops are one of the ways you can have a block of code execute multiple times. A for loop has three parts separated by semicolons. The first part is initialization. In this first part, you can set up new variables for use only within the for loop's block of code. In the example below, we initialize a new integer I to be equal to the value 1. The second part is a conditional. The for loop will continue executing its code while the condition is met. When the condition is no longer met, execution moves to the line beneath the for loop. In the example below, our conditional states that while I is less than or equal to 5, execute the block of code in the for loop. The third part of the for loop happens at the end of every iteration of the loop. In this example, we are adding 1 to the value of I. If you are confused by the syntax or wording of this bit of code in the example, that's okay. I++ is just a shorthand way of saying add 1 to the value stored in I. For each loops are similar to for loops, but they give you an easy way to iterate over elements in a group. In this example, an array is initialized with some numbers in it. The for each loop underneath it then is basically saying for each integer element in the fib array, do the block of code in this for each loop. Per iteration of this for each loop, it is taking the next number in the array and putting it in the variable named element, and then running the code within the for each loop with that new value. While loops are another way to do a block of code multiple times. While loops contain one conditional, and while that conditional is true, the while loop will execute. This example while loop happens to be very similar to a for loop. You can see in the line prior to the while loop, we are initializing the variable n to 1. In the condition, we are checking to see if n is less than 6. If it is, we execute the block of code in the while loop. At the end of the while loop, we are adding 1 to the value stored in n. When the end of a while loop is reached, the condition is checked again, and if the condition is still true, then the while loop executes again. When the while loop's condition is false, execution moves to the line below the while loop, and the code within the while loop is not executed. One difference between this while loop and the for loop we showed earlier is that the first value initialized in our for loop is only usable in our for loop. In this while loop example, that variable, n, continues to be accessible even after the while loop is finished. This is because of a concept called namespaces, which we will talk about another time. Okay, now we need to talk about moving through code. Code executes from top to bottom, meaning that lines above happen before the lines below. And you can think of code executing as a series of walks and teleportation. You walk line by line until you reach a function call or a call to a method, and when you make that function call, you teleport to that function, and then you walk to the end of that function before teleporting back to the line below where you made that function call. In this example, let's say we are executing the late update function. We start with the if statement, and let's say its conditional evaluates to false. So we teleport down to the line below the if statement because we don't execute the block within the if statement. The line below is blank, so we walk to the next line, which is a function call to the faceCharacter function. So now we teleport to the first line in the faceCharacter function's block of code. We execute that line, and now we are done with the block of code in the faceCharacter function. So we teleport back to where the function was called, but the line below it. Now we have another function call, so we teleport again, and we continue as we have been in this example. Now we are going to look at something a little more complicated, but only briefly. Classes, Unity scripts, and methods. A class lets you organize and separate your concerns based on what you want each class to do. For example, you might have a player movement class that handles all the movements the player can make. The scripts you write for Unity will start off with a start and an update function. The start function executes when a scene is first loaded in. The update function executes every frame. You can think of a frame as a single turn in checkers, it just happens really quickly. Methods are the functions you write inside your own class. Methods can be public, protected, or private. A public method is usable outside of this class, and a private method is usable only within the class it is created in. All methods are private by default. We've covered a good deal of information here, but there is always more detail to dig into. You can find more information on Unity's Application Programming Interface, or API. Unity's API contains both information on making changes in the editor as well as through scripts. It contains documentation on both C# and JavaScript, but the majority of the community seems to use C#, and you'll have an easier time finding information on their forums about C# code. Google will usually direct you to helpful information if you search something along the lines of Unity, C#, and whatever you are having issues with. There are also many tutorials on YouTube that can help give you a head start. One example is Quill18, who has a number of walkthroughs on making games in Unity. If you have more questions, feel free to ask or request more detail on specific topics, and hopefully I'll have time to make a video going more in depth.